In this video, I'm going to be working several examples from this section. In the first three problems, we're told to write each in expanded form. So the first one we have is 7 to the power of 4. And if you recall, expanded form is just actually seeing the multiplication that's taking place. So 7 to the power of 4, the base is 7, so that's going to be our factor. And we're going to multiply 7 by itself 4 times. So 7 times 7 times 7 times 7. And that's going to be number 1, because we're writing each of those in expanded form. So what will number 2 look like if we have negative 4 and this is cubed? Well, because we have parentheses, the number that we're dealing with is negative 4. So our base is negative 4, and we're going to multiply negative 4 times itself 3 times. So this is going to look like negative 4 times negative 4 times negative 4. And that's number 2. Number 3 is the opposite of 6 squared, or you could say negative 6 squared. You have to be very careful with this problem though, because how is number 2 and number 3, how are they different? Well, number 2 has parentheses around that negative 4, so it includes both the negative and the 4 when dealing with the exponent. Well, number 3 doesn't have parentheses, so the squared only goes to the 6, and this negative sign out front is just going to come along for the ride. It's just saying the opposite of whatever 6 squared is. So we're going to write this, the opposite of 6 squared. So the negative doesn't occur every single time the 6 does, only one time out front. For the next 3 problems, we're told to write each of these in exponential form. So right now it's written in expanded form. You have all of these numbers being multiplied together, but we want to write it as an exponent. So I know my base is 2 because 2 is the number we're multiplying over and over and over again. And how many times are we doing it? 1, 2, 3, 4, 5. So it's going to be 2 to the power of 5 for that first problem. Okay, next one has negative 3 times negative 3 times negative 3. And notice we have parentheses here because the 3 and the negative are together in each case. So we're going to write it as negative 3. And then how many times does negative 3 get multiplied by itself? 1, 2, 3. So we're going to say it's negative 3 cubed. In the last example, we have the opposite of 8 times 8 times 8 times 8. So, since the negative just appears one time out front, then we're going to write it that way when we do it in exponential form. And there will be no parentheses because we don't have any parentheses here. So 8 is the number that we're using, and 8 is being multiplied by itself 1, 2, 3, 4 times. So this one is the opposite of 8 to the power of 4. In this section, we're told to simplify each one of these expressions. So the first one is 2 to the power of 4, which we could first put that in expanded form and say 2 times 2 times 2 times 2, and we see that 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can say 2 to the power of 4 is going to be 16. The next one is negative 7 to the power of 0. Well, we said before that any non-zero number raised to the power of 0 is 1. So negative 7 is indeed non-zero, so this value is just going to be 1. Okay, the next one here is 4 to the power of negative 3. When we have negative exponents, recall, we need to take the reciprocal and we can make it a positive exponent. So instead of being 4 to the negative 3, we're going to have 1 over 4 to the positive 3. And then we can write that in expanded form. We can say 1 over 4 times 4 times 4. 4 times 4 is 16, times 4 more is 64. So this answer will be 1 over 64. In number 10, we have k to the power of negative 4. So like the previous example, this negative exponent needs to be dealt with, and we're going to do that by taking the reciprocal of this k, so it's 1 over k, and then that will cause this negative exponent to be a positive exponent. So when we do that, we'll have 1 over k But instead of having a negative 4, we now have a positive 4 in our exponent. And we can't go any further than that since we don't have a value for k. It's just a variable here, unknown, so 1 over k to the 4th. Number 11 is 2 times a to the negative 6th. Some students have some problems with problems like this because this negative 6 exponent, they want to say goes to both the a and the 2. But there's no parentheses around the 2a, it's just 2 times a. So it's kind of like we had those negative signs in those previous examples. The negatives just come along for the ride. So this 2 here is just a 2. There's no exponent on him, so he's just going to come along for the ride. So what we have to take into consideration here is this a to the negative 6, and this is the only negative exponent here. So the a to the negative 6, well, the a will go on bottom and become a positive 6 with the exponent. That 2 doesn't move because there's no exponent on him. He's just 2, and he's in the numerator, so he's going to stay in the numerator because we're not told to move him and there's no reason to put him anywhere else or change him, so he's just 2. So this problem is 2 over a to the 6th. Number 12 is similar to this problem, except that our negative exponent starts on bottom instead of starting on top. So we have 5 over x to the negative 3rd. So that means the 5 is fine just where he is. But this x to the negative 3rd, we don't like that negative exponent, so we're going to have to move him from bottom to top. And then when we do that, he will become a positive exponent. So this is 5 times x cubed. In number 13, we have b cubed times 4 to the power of 0. Well, we know that any non-zero number to the power of 0 is just 1. So this 4 to the 0, we could actually cross out right there and just call him a 1. So now we have b cubed times 1, and we know that anything times 1 is just the anything. So multiplying this b cubed times 1 really doesn't do anything. So we're just going to have b cubed. Okay, for number 14, we have a to the negative 3rd over d to the negative 2. So both of these are negative exponents, so one at a time we can move them to where they belong. So a to the negative 3rd will go to the bottom and become a to the positive 3rd. And this d to the power of negative 2, which is in the denominator, will move up to the numerator and become d to the positive 2. So basically we just switch those two around, put the bottom one on top and the top one on bottom, and change the exponents from negative to positive. In number 15, we have 7 times x to the power of 0, y to the power of negative 3. Well, like we saw in number 13, when we have this power of 0, we can just cross this thing out and call it a 1 right there. So now we really have 7 times 1 times y to the power of negative 3. Well, 7 times 1 is just going to be 7, so I can put him there. And then y to the power of negative 3 will go to the denominator and become y to the power of positive 3. So that's all we can do for that problem. Okay, one final example. We have 16, and number 16 says x to the power of negative 7 all over 3w squared. So the only thing that looks like is a problem here is this x to the negative 7 because it's a negative exponent. This 3 and then w squared looks just fine where it is, so we can leave him in the denominator. So, since we're going to leave the 3w squared in the denominator, we'll go ahead and rewrite them right there where they belong. And this x to the negative 7 will now go from the numerator down to the denominator and become x to the positive 7. Well, you got to be really careful here. Now that we've moved this out of the numerator to the denominator, you can't just say the answer is 3w squared x to the 7th, because this stuff is in the denominator. So what is it that's in the numerator? Well, it's just a 1, because everything got taken out, and we leave it just a 1 in the numerator. So this video covered several examples of having integer exponents.